Okay, problem 50, we're going to be taking a look at a bunch of fractions, and we can use fraction busters for each of these. So in the first problem, 3x over 5 equals x minus 2 over 4. Again, fraction busters. I need to look at my denominators and find a common denominator. My common denominator between those two is going to be 20. So I multiply the entire problem by 20. What that does is I distribute it here and here. So when I put 20 in my numerator and 20 in my numerator, I should be able to reduce. So before I go any further, I'm going to reduce 20 over 5 is going to reduce down to 4 over 1. And over here, 20 over 4 is going to reduce down to 5 over 1. This now gives me 3 times 4 times x, and 5 times x minus 2 I'm going to distribute, so I have 5x minus 10. I no longer have any fractions, so now I'm just going to get the x's on the same side. So I have 7x equals a negative 10, and then I divide by 7. I get my x value being a negative 10 sevenths. So looking at problem B. So problem B, my only denominator I have is x. So I'm going to multiply everything by x. Multiply here, and multiply here. X over x makes a giant 1. I'm left with 4x minus 1 equals 3x squared. Again, I no longer have fractions. This is a quadratic. I have an x squared and an x term, so I want to set it equal to 0. I'm also going to keep my leading coefficient positive, so I'm going to keep that where it is, and I'm going to move the other 2 to the other side. That gives me the equation of 0 equals 3x squared minus 4x plus 1. This I can factor. So I have my 3x squared, positive 1. Make my diamond problem of 3x squared. My middle term is a negative 4x. That is going to give me a negative x and a negative 3x. So negative x and negative 3x. I can now factor out that generic rectangle, give myself a little room. So I'm going to have x here, which means that's a 3x, which means there's a negative 1, and that's also a negative 1. Negative 1 and negative 1 gives me positive 1, so that's my check to see if I have it correct. Now in factored form, I have 3x minus 1 and x minus 1, and they do equal 0. So zero product property, I take this and set it equal to 0, and when I solve that, I need to add 1 and then divide by 3, so x is a positive 1/3. Set this equal to 0, and I get positive 1. So those are my two solutions. Taking a look at problem C. Alright, so 3 different fractions, and there's a couple things I could do here. Since both of these have a denominator of 3, one of the options would be to add 1/3 to both sides, and then I would just have essentially a proportion. But I'm just going to use fraction busters because that's the way I was using the other ones. So my common denominator between the 5 and the 3 is going to be 15. So I multiply everything by 15. And now I reduce. 15 over 5 is 3, 15 over 3 is 5, and again 15 over 3 is times 5. I can now write my next line without any fractions. 2x times 3 is going to be 6x. 1 times 5 is 5, so I have minus because I have a minus there. 5 equals, and now 137 times 5 is going to be a little bit of a bigger number. And that is 685. I now no longer have fractions, so I add 5 6x equals 690, and I divide by 6, and x ends up equaling 115. And then I have one more problem to do, problem D. Now in this problem again, just like in problem B, I just have the one denominator as x plus 1. So when I multiply everything by x plus 1, so it goes up here, x plus 1, that makes a giant 1, and I multiplied here x plus 1 as well. That gives me 4x minus 1 on the left side, and on the right side I multiply these two together. You may notice they are a difference of squares. It is going to be x squared minus 1. Setting everything equal to 0, moving this to the right side so I keep my leading coefficient positive. I'm going to subtract the 4x and add the 1, so those actually cancel out. I can factor this. They both contain an x, so I can factor an x out of them, leaving x minus 4. And zero product property, either this equals 0, so it gives me an answer of x equals 0, or this equals 0, which gives me an answer of positive 4.